of it. Hey everyone, and welcome to the Algebra Dudes. I hope you've had a great time so far today. I'm Reginald Samuel, algebra teacher, or actually I'm an algebra coach for Dallas Independent School District.
Okay, hi, I'm Nadia Ayala, algebra teacher at WT White High School. We're looking forward to a great year with you right here on Algebra Dudes.
I'm moving a lot because I'm trying to make sure I'm right in the screen. Okay, here we go. We would love to hear from our Algebra 1 students as we solve text type questions. It's important to understand that algebra is 50% of the 9th grade test and 10th grade test, and it's 40% of the exit level exam. So remember that every problem we solve here on the Dudes is a tax type problem. You may want to hang on to your notes to review for the tax test coming up in April.
Okay.
Alrighty.
Teachers, please make sure to fax in the weekly student attendance forms that include the student name, ID number, grade, and name of the math teacher. Before we get started, let's go over a few housekeeping rules. Please, when you use your telephone to give us a call, turn the TV volume down a bit to avoid the feedback noise. It really hurts our ears.
Yes, it does, guys. Remember also that cell phones do not work well with our audio system, so be sure to use the regular phones. Please, no cell phones. I thank you. Our ears thank you. And Nadia.
Yes, thank you.
Miss Salinas. Miss Salinas.
Okay, also, what's going on? Hi. Also, a lucky caller will win this great gift today, guys. It's pretty cool today. We have a calculator like usual. We're going to have a calculator.
Woo!
And then it comes with a little watch.
I mean, can't we
a guy
give away,
watch and a girl watch.
Can we give it like 3 gifts?
This is 3 gifts, you
guys. Are we going to give it
guys.
all away at one time, or?
I guess so. It was all in the bag, so
Let's do like 3 gifts. Let's give so we have 3 different callers that can win gifts.
Okay, well, Mr. Samuel's changing the rules.
No, I'm not changing the rules. I'm just saying we have 3 gifts. So a guy, a girl, and then of course.
Okay, so we'll draw 3 names today.
Yeah,
So-
sounds good. Sounds good.
That'll be fun. We'll draw a name for the calculator. We'll draw a name for the girl gift, which is a cool watch. And then we'll draw a name for the guy watch.
Sounds good.
It's
So
a
those of
great
you who are
idea.
back there listening, make sure we get 3 people today. We need a guy, a girl, and anyone else because the calculator can go unisex. Okay.
Okay, good luck, callers. And we haven't forgotten you, teachers. We will have a monthly drawing for a great prize for a lucky teacher. Woohoo! Then at the end of the school year, we will have a super prize for the lucky caller who is randomly drawn from the prize box. So good luck, everyone.
Okay, the number to dial is 972-925-3123. Let's go ahead and get started. But before we get started,
What?
I need to know, I've been out for 2 weeks.
Yes, welcome back,
so,
Mr.
hey, welcome
Fabio.
back to me. All right, now, what have we gone over pretty much for the last 2 weeks?
What have we gone over? Okay, we've gotten an equation of a line.
Okay.
I would give them the graph. We went over from standard to change it to slope-intercept form.
Oh,
Yeah,
cool.
we did
Oh
that.
my God,
And,
okay.
and I gave them a table also, and they gave me the equation from a table as well. We went over x-intercepts, y-intercepts. We did a lot.
Oh my
while he was
God, so
gone.
they are bright out there. Okay, so I'm looking for some wonderful callers to call in and let me know what's going on with the problems we have today. Let's go ahead and look at the Elmo over here and look at what we're dealing with today. We are dealing with, I hear that the Elmo is going to be coming up pretty soon, but while we're waiting on the Elmo to come up, we're going to talk about, graphing, completing tables,
Yes.
and writing function rules when given. First, we're going to deal with a slope and a y-intercept. We're going to deal with the slope and the point, and when 2 points, okay? That's what we're dealing with today. That was hilarious. I was actually reading from another screen when somebody came in and quickly took the page away. So, but I have it now. And
That's
let's go. Okay, we are hot, and I'm scared because I don't know if we're going to be able to go to the Elmo.
Okay,
But hopefully-
we'll entertain you guys or wait.
Yeah. Actually, do we have any callers out there that we can go ahead and take so we can hear
Do we have any callers,
how
guys?
some days were going?
Guys? This
Okay,
is great
they're not back
technical
there.
people here that we've
Okay.
got.
They are
awesome.
wonderful.
They're
They're wonderful.
Oh, hi. Who's on the phone? Is somebody on the phone?
Hello. Okay.
They're lying to us. They told us, hi, say hi. I don't think
Hello?
anybody's there.
I don't know, unless there's something wrong with the audio system. We don't hear anything that you all are hearing. I guess the phone caller that you all are saying that's live is not live on our earpieces.
Okay. So how was your wedding? He got married, you guys. That's why he hasn't been here.
Yeah, I got married.
Yeah, he went.
Okay.
We're ready?
Okie dokie. Well, they're ready, they're saying, and so I don't
we
know if
can't
are you all ready for the Elmo, or you're ready? You have someone coming in. We don't hear anybody, and the Elmo is not coming up, so we're not understanding your.
Okay,
Okay, the Elmo is ready. Oh, well, definitely go to the Elmo. I wanted to go to the Elmo. Okay, here we go, guys. Again, this is what we're dealing with today. We have graphing, completing the tables, and writing function rules when given these three different things. We're going to deal with slope and y-intercept, the slope and the point, and when given 2 points, okay? So let's go to that first caller, and we're going to look at this first problem while we're... Uh-oh, did you all see that?
Rody,
that
what was
wasn't
that?
what you all were supposed to see. Okay. Here we go. Let's deal with this first problem while we're
Okay, I think we have a caller. Hi. I think I heard Jonathan.
Yes.
Is this Jonathan?
Yes, ma'am.
Hi, Jonathan.
How you feeling, Jonathan?
All right.
Okay, you ready to work a problem, Jonathan?
Yes, sir.
Okay.
Where are you calling from, Jonathan?
W.H. Atwell Middle School.
Okay, so Atwell sounds good. Tell Miss Branch I said hello over there. But let's go ahead and work this problem. Can you see it on your screen?
Yes.
Okay, sounds good. Here we go, Miss Salinas, and I'm going to try to get that name right now. She is going to read the problem. Okay, here we go.
Okay, we've got a table, and it says roses are red, charges a $10 account setup fee, and $2 for each rose purchased. Complete the other 3 sections. Okay, so we've got a table, and here we go.
Okay, here we go. So, what do you want to do first? You want to complete the table first? You want to do the algebra rule for it, or the function rule for it, or you want to graph it? Talk to me.
The algebra rule.
You want to do the algebra rule first? Okay, here we go. Dealing with this, let's go ahead and look back at the scenario here and tell me what I can underline that actually has some meaning to, or some validity to, this particular section.
The
Okay.
setup fee.
Okay, we know that. Okay, the setup fee. And how much is the setup fee?
$10.
$10. And okay,
Great job.
how does that affect me right here? Is that my slope, my y-intercept?
That's your y-intercept.
That's my y-intercept. Excellent job, man. Okay, so now let's look at this, the rest of the problem. It says $2 for each rose purchased. What is that?
That's the slope.
Okay, talk to me about slope, and I want you to give it to me in rise over run form. We know that we're talking about
2 over 1.
Perfect.
excellent job.
Woohoo!
Excellent job. 2 over 1, because we're talking about a rate of change, and so for every $2 you spend, you get 1 rose. So good job. So let's go down here and fill in this section. It says to write the equation or the function rule. So what would it be?
Y equals 2x plus 10.
2x plus 10. Excellent job. You're all over this problem. Okay, so let's go over here to the table now, Jonathan. Tell me what I'm doing here.
You fill in y's.
Okay, let's fill in the y's. And this, give me another name for this. This is my y's, it's my output, it's my total cost, it's also my what?
Your function. Your function of x.
Okay, it's the change in y. We know this is my y, but is it my independent or my dependent? See,
What do you say?
is this my independent or my dependent variable? This is one and this is the other.
It's your dependent.
Dependent. Okay, good deal, good deal, good deal. I know you might have had a little help from above, but okay, come on with it. Tell me, if I don't buy any roses, but I just want to set up an account with them, how much am I going to pay?
$10.
$10. Good job. Okay. Now, what about if I buy 5 roses from them?
That would be 20.
That'll be $20. Tell us what you're doing.
You putting 2 times 5
Okay, so I'm plugging in my 5 here. So I have 2 times 5, and then what?
plus 10,
Plus 10, and it gave me
20.
20. Excellent job. So keep on going. Now we can go ahead and go with them now that everyone knows what we're doing.
All right. 2 times 10 plus. That'd be 30.
Good job.
Good.
Next one would be 50.
50. Okay.
And what's the last one?
What is 50?
That's a 50.
Mm-hmm.
That'd be 110.
Okay. 110. Good job. Good job. Now let's go ahead and quickly graph it, and we're going to graph it according to the let's use this. Let's use our slope and our y-intercept. Okay. Or actually, we can say we're using this information right here. Okay, so utilizing this information, let's come over here and what would my x-axis be labeled? What is it? Is it my number of roses? Is it my total cost? What is it?
It's your number of roses.
Okay, number of roses. Okay, and what about over here? What is
It's
this?
the cost.
That's my total cost. Good deal. Okay, so now that we have that information taken care of, what am I going to count by? Knowing that this is my origin, what am I going to count by?
Can you repeat that?
What am I going to count by on my roses?
5.
I can count by what?
5.
5s. Okay, 5. Let's say that's 10. Okay, 15, 20. Okay, that's cool. Now, what about over here on my y-axis?
You can put that by 10.
I can count by 10s over here. Okay, I'll count by 10s. 10, 20. Okay, 30. And 40. That's good. Okay, that's enough information. So now, let's start with the y-intercept. Okay, let's start with the y-intercept. What am I going to do with this 10 on my graph?
You start at 10.
Mm-hmm. Okay, so I start at 10. Am I going to this 10?
No, you're going up.
I'm going up 10. Good deal.
Good.
Because it's my y-intercept, so I'm going to put it on my y-axis. Okay, so now I have a point right here. What do I do from this point? Using my rise over my run.
You move over.
I'm going to go over first. Am I going to run or am I rise first?
Plus the rise.
Rise first. So I'm going to use my rise first. So where am I going to go?
20.
I'm going to go up 20.
Oh,
You can go up 20. But if you go up 20, how many are you going to have to go over?
10.
10.
10.
Okay. So you want to go up 20 and over 10?
That's fine.
That's fine.
You can do that.
10, 20, and then over 10. Okay? That's fine. That's perfectly okay. All right? So now I have 2 points. What can I do from here? Talk to me, Jonathan.
Good. You could draw your line.
I can draw my line. Good deal. So let me go ahead and get my ruler out because they got on me about not using my rulers. So make sure you all are using your rulers out there to make nice, pretty lines. Okay, good deal. So here is my y equals 2x plus 10 line.
Yay.
Good job. Good job. Here we go. Let's give you
Jonathan. Great
100
job.
and a check. That's a 100, Jonathan. Good job, man.
Thank you.
All right, keep calling in. Bye, guys. Bye, Atwell. Okay.
100 and a check. That's great.
Exactly. They don't get the little usual happy faces with me.
They've had my happy faces for the past 2 weeks.
Cool.
Probably tired
Okay.
of 'em.
No, they're not. No,
Yes,
they're
they are.
not. Ryan, are you there?
Hi, Ryan. Ryan.
Yes, I'm here. I see him.
Hey, Ryan. What are y'all doing?
Nothing. Oh my gosh, acting so bad. Dallas is.
Huh?
I said Dallas is acting bad.
Okay. Thanks.
Dallas, act good. Be nice.
Yeah.
Is Jasmine there?
Yes. Jasmine's here.
Okay. Tell him I said thumbs up.
He's putting a thumbs up.
Thumbs up, guys. Not down. Thumbs up. Okay, let's go. Let's go to work, Ryan.
I can't. I can't hear.
Give her a hard one.
No.
Oh, you want a hard one? Okay, I won't give you a hard one. I'll just give you a different problem than I was going to give you.
Okay.
Alrighty, here. Let's deal with this one right here. Okay, here we go. Let's go to the Elmo and see what's going on with this problem. Go ahead, Miss Ayala.
Okay, Ryan, it says Liz is walking towards a motion detector at 2 feet per second.
Okay.
You missed where You missed where she started, but you know that she was at the 5-foot mark when the timer called out 3 seconds. Okay, do you know what a motion detector is, first of all?
Yeah, the things we walk through in the morning?
No, not a motion detector like that. It's a motion. It's more like a. Have you all dealt with CBRs where you have like a little ranger sitting at the end of a desk and the student walks back and forward?
No.
Y'all hadn't dealt with that. Well, I'll tell you what. It's that type of motion detector. Let's just look at the problem because the problem doesn't necessarily lend itself to you needing to know what a motion detector is. All right.
That's a metal detector, Ryan, that you're talking about. Okay.
Okay, you ready?
Yes.
Ryan? Here we go. All right. Okay, this is the information we know. All right.
Okay.
We know that we have a time and we have a distance, right?
Uh-huh.
Okay. Now, it's 2 bits of information that this is giving me. First of all, it says that Liz is walking toward a motion detector at 2 feet per second. Okay, so what information do you think that is?
Hold on, I can't really hear you.
Okay, are they being loud back there?
Yeah, kind of, sort of.
Uh-oh. Yeah.
I'm sorry, can you repeat it?
Okay, what is 2 feet per second? What information do you think that is?
2x?
But I mean, it's, okay, that 2, in 2x, that 2 is your what?
That's my slope.
That's your slope. Okay, so this basically is giving you your slope. So we know our slope is 2 over what?
2 over 1?
2 over 1, because for every 2 feet, you go 1 second. Okay, now, do we have our y-intercept?
Yes.
Okay, we do. It says,
Oh, no.
You missed where she started. So that means, if you miss where she starts, that means you don't know her y-intercept, right?
Uh-huh.
But you know that she was at the 5-foot mark when the timer called out 3 seconds, okay?
Uh-huh.
So let's go over here and let's say we have, let's just use 0, 1, 2, 3, and 4, all right? Now, in the times that we have, which one do we know?
3, 5?
We know it's 3, 5. Good job, okay? So now, can we fill in the rest of our table?
Yes.
Okay, because we know that she's going 2 feet per second, so
You
also,
would subtract 2?
good deal. Okay, so here we go. We know that if it was 5 here, then it's going to be what?
3.
3 here, and then if it's 3 here, it's going to be
1.
1, and then if it's 1 there,
negative 1.
then it's going to be negative 1, which means she started behind the motion detector, and then when the motion detector started reading her, they actually read her at 1 foot, okay? Because you can't have negative distance, all right?
Okay.
Okay, so here we go. Let's look at the y-intercept. What's my y-intercept here?
0, negative 1.
0, negative 1. Excellent job. 0, negative 1. All right. And let's go ahead and fill in the rest of our table real fast. What is it?
7.
7. Good job. Okay, so now let's talk about our function rule. What would it be? We know our slope and we know our y-intercept.
Y equals 2x.
Y equals 2x.
Minus
okay?
1.
Minus 1. Excellent job. Okay, so now let's talk about labeling our axes. What would this axis be?
That would be your distance?
This would be my distance. You sure?
No, I mean your time.
That's my time because I know this is x and that's y, right? Okay, so we have time, and then over here we have
Distance.
Excellent job. So now, what are we counting by?
You're counting by 1.
Good deal. So we can say that this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, and over here this is going to be 1, 2, 3, 4, 5, 6, 7, and we'll stop there. 1, 2, 3, 4, 5. Put a 5 right there. Okay, so here we go. Let's talk about actually graphing this. So where am I going first?
You're going to go to 1, 1.
I'm going to go down 1, so I better put a down 1 right there. Okay, so this is going to be down 1 and put a dot. So then what do I do?
you're gonna go up 2 over 1.
Okay, up 2. So let's go up 2. If I go up 2, am I counting the x-axis? Do I need to count that?
Over 1.
No. My question is do I need to count the x-axis when I'm going up?
Yes.
Definitely. Good job. Okay, so I'm going up 1, 2, and then over 1. There is my second point. Can I draw a line now?
No.
Yes, I can.
Well, you can, but I would make more points.
You want some more points? Cool.
They're used to me, that's it.
Yeah.
Okay, let's go. Let's do another one. Where do I go from
go
here?
up 2 over 1
Up
again?
2, 1, 2 over 1. Okay, and then where?
Then you go up 2 over 1
Up
again?
2 over 1. Good job.
Now you can now you can draw.
Now I can draw my point. Okay, good deal. Good deal, Miss Salinas. You're teaching them right.
Sorry to be so picky.
Let's see. Okay, so here we go. There is our line, and this is my y equals 2x minus 1. Good job. Good job.
Can I have a smiley face?
Of course you can have a smiley face. 100 and a check. Good job.
It's not a smiley face.
Oh, you want a smiley face? Okay, here we go. Smile. You made a
Oh,
wonderful.
yeah. Thank you. Bye.
Good job, baby. All right, here.
Smiley face.
That was a smiley face.
They
It
like
was
the
a-
smiley faces.
I know. I'm just
We
not
need to
good.
get
I'm
little
not good
stickers.
at
And
smiley
we'll put
faces.
little stickers on.
Yeah, I need little stickers because I'm not good at the smiley faces.
Okay, I didn't hear the name correctly, but we have a student from Spruce.
Okay, Gloria from Spruce. Hey! Uh-oh, is that Spruce? All
Yes.
right, Spruce. Okay, this is actually where I am. Spruce now.
I know who you are.
Yeah, I think.
Hi, Gloria, is that you?
Mr. Samuel, we want to debate the last problem that the girl did.
Okay, you want to debate the last problem that the girl did? Okay. Okay. Uh-oh, and I see why.
Cause they
let's go
walking
back.
towards and they not walking from it.
Uh-oh. Let's go back to the Elmo. Go back to the Elmo. Okay. You know what?
Uh-oh.
That would be correct. That would be correct. Uh-oh. So you know what? With that, we're going to give you one for them walking toward. Let's give you one of them walking toward. Okay. Here we go. I mean, this one is not going to be that difficult, but it's going to be one of them walking toward so we can look at what we should have done. So let's go to the Elmo now. Okay.
All right.
Here we go. Now, Miss Salinas, go ahead.
Okay, it says Sam is walking toward a motion detector at 3 feet per second, and he started 15 feet away from the motion detector.
Okay. So here we go. Let's fill in the information that we know. First of all, let's look at, let's talk about, what information can we fill in?
3 feet.
Okay, 3 feet is my what? 3 feet per second is my
It's
what?
a slope.
Okay, good deal. Okay, and what about my y-intercept? Do I know that?
It's 15.
Good deal, because I started 15 feet. Okay, 15 feet away from the motion detector. Okay, so here we go. Now we're walking toward. So I know that my first point, if it's 0 time, is it going to be, what is the distance going to be?
15.
15 feet. Good job. All right. So now, 1, I'm walking toward the motion detector, and I'm going 3 feet per second. So after 1 second, it should be what?
12.
12. Excellent job. And then after 2, it's going to be?
9.
9. Good job. Okay. After 3, it's going to be?
6.
6. And then after 4, it should be?
3.
3 seconds. Okay. 3 feet away. Okay. Good job. Good job. I'm loving it, Spruce. I'm
And
loving
then 3 supposed to be negative
That 3 should be negative. I don't know about
on
that
the
one.
slope.
Oh, this 3 should be negative on the slope. Good
good,
job.
good.
See, look at you. Look at you correcting me and stuff on TV.
I didn't buy him his coffee today.
Yeah,
So.
I didn't get my Starbucks today.
No.
Okay, here we go. So let's talk about a function rule.
All right.
Okay, here we go. It's going to be y equal what?
Is negative 3
Negative 3.
x plus 15.
Net plus 15. Good job. Good job. Okay, so now let's go over here to the graph. What we got going here?
All right. Time is on the x
Time is on the x.
and distance is on the y.
And distance is on the y. Let me see if I can write that. Distance is on the y. Okay, so now what am I counting by, or what's my scale factor?
1 on the x.
Okay, you want to count by 1s on the x. Okay, 1, 2, 3, 4, and then that's 5, 6, 7, 8. Okay, what about on my y?
On your y, it'll be 5.
You want to count by fives? That's fine.
All right.
That's fine. We can count by fives. 5, 10, 15, 20, 25. Okay, so let's put this as 5, and we'll skip to 15 and then 25. Love to skip numbers. All right, so here we go. Let's talk about this. Now, where are we starting from?
We're starting from 0, 15.
0, 15. So I need to say, where am I going on my X? Do I need to go out here to 15, way out here somewhere? Or do I need to go up?
Up.
Good job. So I know that my 15 is right there, so there is my y-intercept. Now, tell me this, what is my graph going to look like? Is it going to be a negative looking graph or a positive looking graph?
Negative.
Negative because of my slope, right?
Yay.
Yes, sir.
Good job. You're all over this problem. So here we go. Now remember, you counted by 5, so let's watch how we count. Here we go. We're at 15. Now, where do I need to go from 15?
Down.
Down how
3.
many? Down 3. So I'm not going to quite get to 10, but I'm going to be right there at 12. And then what?
Say it again.
I'm going to go to 12, and then where do I go from there?
Over 1.
Over 1. Good job. Look at you. Look at you. Okay, there it is. So let's keep going. Now, where am I going from here?
You're going to go down 3
Down 3.
and over 1.
I'm going to go down 3 and over 1. And I'm just past that tick mark because I know that's 10, and I'm going down to 9. All right, good job. Then where?
And then go down 3 again.
Go down 3 again. I'm going to be right above this because that's 6, okay?
And then you're going to be over 1.
Then over 1. Good job. And is that enough points to go ahead and graph?
Yes, sir.
Sounds good. Okay, let's go ahead and look at it then. We're going to say that that is...
Ow, my ear.
Ouch. Okay. And this is my y equals negative 3x plus 15.
Can you explain what the x-intercept's going to mean?
Okay, let's talk about the x-intercepts. Let's talk about the x-intercept. If
Yeah.
I keep going, let's just say I keep going on my table, right? I'm going to have 5, and then what is my distance going to be?
0.
0, okay? Alrighty, now that means that my point will be right here, and this is called, what point is this? That's called my
Your x-intercept.
x-intercept, okay? And what does that mean? When I get to 5, 0, according to this situation, what does that mean that Sam has done?
You're at the motion detector.
Good job, good job, excellent job. And this is, who is this? Let me see, this is Gloria. Gloria, excellent job, baby. I don't do those little smiley faces good, but I'll give you 100 and a check. Good job, good job.
Thank you.
Spruce High School, you all keep calling in, and you all are representing me this year. Last year I was at Carter High School, but now I'm at Spruce. So I look forward to Spruce calling in a great deal, and all the schools need to call in. All right, here we go. Next caller.
Okay.
We have someone from Griner.
Yeah, we can't hear you
Someone
too
from
well.
Griner. Go ahead.
Okay. Hi, what's your name?
My name is Letty.
Letty. Hi, Letty.
Hi, Letty.
Hi.
How are you doing?
Fine. He's just nervous.
How many of you guys are there?
There's only 4.
Only 4. That's good.
Tell me this, Letty. How good are you with the problems? Are you doing a good job out there, or you need something a little bit lower, a little bit more?
A little bit lower.
A little bit lower.
Yes.
I always get that answer. Well, don't you all? Okay, here we go. Let's deal with Rose problems, because I know
Yay.
all of you all have dealt with Rose problems to some degree. Okay,
ready,
here we
Letty?
go.
Yeah.
Okay, here we go. It says Roses Are Red charges a $20 account setup fee and $1 for each rose purchased. Complete the other 3 sections.
All righty, Letty, you ready?
Letty?
Yes.
Letty?
Are you
Okay,
ready?
here we go. What part do you want to fill out first? This algebraic section, the graph section, or the table section? It's all up
table.
to you. The table. Now, I hope everyone out there is understanding that these are all the same thing. It's just it's represented differently. Okay.
Okay.
This is just different representations of the same situation. All right.
All right.
So here we go. Let's talk about the table first. Okay. We know it's a $20 setup fee, and it is a $1 rose charge. So tell me this: if I buy 0 roses and I just want to set up an account, what am I going to be charged?
$20.
$20. Good job. So it's 0, 20. Alrighty, now I go back the next time. I've set up my account. So I've already put $20 into this, and now I want to buy 5 roses. How much are they going to charge me?
25.
$25. That's the $20, and then plus the 5 gives me my 25. Okay, let's go. And 10 roses.
30.
30. Good job. Okay.
35.
35. You are getting good at this. Okay.
Yep.
Uh-oh, wait a minute now. I skipped to 50.
70.
70. Good job. Excellent job. Excellent job. I should have given you a harder problem. I knew I should have given you something harder. Okay, here we go. Let's look at the algebraic situation. Let's talk about slope. What will my slope be?
1/1.
1/1. Excellent job. Excellent job. I like the way you said 1/1 because you know it's a rise over a run. $1 for each rose you purchase. Good job. What about my y-intercept?
0.
0.
20.
0, 20. Good job. Excellent job. Look at you. Yeah, you bet. When you call in, I'm going to give you a different type problem. All right, here we go. Let's go with our equation. Y equals
X plus 20.
X plus 20. Good job. That is perfect. And we already know that if there is no coefficient here, then the coefficient is 1. Okay, so let's go over to the graph. Talk to me about my x-intercept and my y-intercept.
Number of roses on the X.
Number of roses right here.
Yeah.
Okay.
Good.
And what about over here?
The total cost.
This is TC, total cost. All right, so from there, let's go. I need to put some tick marks or something. What am I counting by here?
By 1.
Let's count by 1s on the roses.
Yes.
Okay.
By 5. By 5. By 5.
You want to count by 5s? You sure you want to count by 5s?
You're okay.
Yeah, by 5.
Okay, I like 1s better,
One
but
was better.
let's go. You
it's
sure?
okay.
Okay, last chance.
No, by 1. By 1.
Okay.
Okay. You see, if you count by 5s, you just gonna. I'm gonna be guessing how far I go over. Okay, so 1, 2, 3, 4, 5. That's my 5 mark. 6, 7. Okay, now up here, what am I counting by?
By 5.
By 5s? Okay, cool. So that means I have 5, 10, 15, 20, 25, 30. Okay, there we go. Now we're gonna do just a few points. So let's go.
Okay.
Alrighty, where are we starting? What's my y-intercept?
0 and 20.
0 and 20. So 0 and 20. So that means that I need to go out to 20 this way.
No.
No, good job. Okay, I need to go where?
Up.
Up to 20. Good job, because we know our y-intercept crosses our y-axis. Good job. Okay, so keep going.
5.
No, we're now using our slope, right?
25.
I'm going to 25.
Yes.
Okay, if I go to 25, how far am I going out?
5.
I'm going out to 5. Good job. Look at you. Okay, you know what you're doing. You're over here using these points. I'm going to get you. You're supposed to be using your slope and going up 1 over 1, up 1 over 1, up 1 over 1. But that's fine. You can definitely use your points. Cool. So I don't want to put any more points up here because if I do, I'm going to be all off the charts. All right?
Okay.
So let's go ahead and take these two, and I am going to take my line, and I'm going to draw it.
Yay.
Yay.
Yay. And this is my y equals
Good, Letty.
x plus 20. Okay. Excellent job, Letty. Here we go. Bam. Check. 100. And some little dots. And a smiley face. There you go.
All right. Thank you.
All right.
Thanks for coming. Good. She did awesome.
Yeah, she did a really good job. I should have given her another problem.
Another one?
Yeah, well, a different problem. Different problem.
Different. They all look the same. I look at them.
No, but I mean, there are some that it does different things. Okay, I was trying to see if the paper actually works. Okay.
We have someone from Atwell. Daria.
Hello.
I hope I pronounced your name right.
Hey, who are we talking to?
Daria?
Hello.
I'm here.
Okay, who are we talking to, dear?
Daria.
Daria?
Yes. I said her
Hi,
name.
Daria. You did a good job. No, I was just trying to make sure that it was Daria because you said.
Because you scared me and her right now. You screamed. Hi, Daria.
Okay.
Hi.
Hi, how are you doing?
Fine.
Good. How many of you
good.
guys are there?
3.
3. Good.
3, good deal, good deal.
Tell your teacher thank you for staying after school. On Halloween.
Okay.
Excuse me.
Okay, yes, ma'am.
Can you go back to the problem, the last problem?
The last
did we
problem.
mess up on that one too?
Dun, dun, dun. Here we go. We're going back to the last problem.
Here we go.
Okay, I don't think this is the last problem. Let me get the last problem, because that's not it. Okay, here is the last
that
problem.
one's it.
This is the last problem. Okay, talk to us. We
Okay,
need to
talk
know
to
if
us.
we make mistakes, we love to be corrected. Go ahead.
On the table, when
Uh-huh.
X is 20, Y is 40.
Y is supposed to be 40.
yeah,
You know what?
she is
That
right.
is correct. That is correct. And you know what? No one told me that but you. And I appreciate that. You get, you know what? You get an extra check for that. And you better get this problem right. You calling and correcting people. You better get this problem right. You ready? Here we go. Let's go to work.
Okay. It says Ty is walking away from a motion detector. So walking away.
Walking away.
For Spruce, we're reading it correctly now.
Yeah, good job. Good job.
Okay, Ty is walking away from a motion detector at 3 feet per second. You missed where he started, but you know that he was at the 7-foot mark when the timer called out 2 seconds.
Okay,
2
okay,
seconds.
good deal, good deal. So we're walking away from the motion detector, the motion detector. So we know that this is definitely going to be what type of slope? Is it going to be a positive slope, negative slope, or an
A
indifferent?
negative.
It's going to be a negative if we're walking away. I think it's going to be a negative if we're walking toward it, because it's like you're getting closer and closer, and the closer and closer you get to the motion detector, the lower your distance is. So if we're walking away from it, I think the greater your distance is going to be. So that's going to be a positive. So, but good job, good job. Let's go from there. Tell me this: what's my slope according to this situation?
What's your what?
Slope.
You rise over your run, sweetie.
Let's see.
3 over 1.
3.
Woohoo!
Look at you. Look at
Yay,
you. See?
she got it.
I knew
knows
she was
what we're
smart.
talking about.
I knew she was smart. Okay, so here we go. What other information do we know?
7 feet.
We know that he's at the 7-foot mark at 2 seconds. So let's go over here and let's say 0, 1, 2, 3, 4, right?
Yeah.
Okay, so at 2, it was, how far was he?
7.
7. Good job. Okay, so now let's go backwards and then we'll go forward. Okay, let's fill in this over here. So if he's going 3 feet per second, then how far would he have been at 1 second?
4.
4. Okay, and then where did he start from?
1.
1 second. Good job. Oh, 1 foot. Okay, here we go. Now what about going outward? He is at 3 seconds. He would be how far?
5. 10.
10. Good job, baby. Okay, and then at 4 he would be
13.
13. Excellent
Good,
job. Excellent job. Okay, now let's talk about my y-intercept. What's my y-intercept?
Your who?
My y-intercept.
1.
It's going to be 1, but if we're doing it in a point form, we want to write it as a point. It would be what?
As an ordered pair, sweetie.
0, 1.
0, 1. Okay, good job. Alrighty, so now let's talk about our function rule. What would it be?
3x plus 1.
3x plus 1. So it'd be y equals 3x plus 1.
Awesome.
That is an excellent job. Okay, here we go. Let's go to the graph.
Let's go.
Here we go. Let's talk about it. What's my x-axis?
Time.
Time. Okay, because that's my x and that's my y. So I'm talking about time. All right, and keep going. What's my y?
Distance.
Distance. Okie dokie. And here we go. From there, I need to know from you, what am I going to count by on my x-axis?
1.
1's. Good job.
Good job.
Okay. 1, 2, 3, 4, 5, 6, 7, and I know that's my 5 spot. Okay, and what about on my y's?
2.
You want to count by 2's? Cool. Okay, that's 2, 4, 6, 8. Who do we appreciate? Okay, here we go. 2, 4, 6, 8, 10. Good deal. Okay. Go ahead. So what am I doing now?
Your Slide 0, 1.
0,
Good.
1. So am I going up to this tick mark? Am I going
No.
up? Nope, because that's what?
2.
That's 2. So I'm going to go in between there and plot me a nice big dot. Good deal. Okay, so now where am I going from there?
To 2. 7.
I need to go to 7.
Yes.
Okie dokie. Let's see. You want to go, okay, so we're going to start back at the origin. You don't want to use the slope. You're going to actually plot the points. So if we're starting back at the origin, where do I go for 2, 7?
Over 2, up
1,
7.
2, and up 2, 4, 6, and half of that would be 7. Good job. Okay. So from there, let's go ahead and draw a line. And that is an excellent job. Y equals
Good, Daria.
3x plus 1. Okay, check and 100 plus your extra check for calling in and getting the
Correcting us.
correcting the problem. Good job. Somebody said yay. Okay, good job, baby. We'll see you. Definitely call us back. Definitely call us
You
back.
almost marked me with the marker.
I tried to, but I didn't get you.
Okay, hi. I think we have Nellie from WT White.
No, Nelly left, Miss Ayala, but this Canberra.
Nelly left.
Hi, Miss Ayala.
She has to go to work at 5.
Oh, cool.
Okay,
bye,
hi,
Nelly.
Kiambra.
Hi.
Uh-oh. Hey, Kiambra, how are you doing?
Fine, how are you?
I'm well. Are you ready to work a problem?
Yes, we missed you while you were gone.
Hey, I appreciate that. It's good to be missed. It's good to be missed.
Hey, Kiambra, how many of you guys are there?
I think it's like 13 or 14.
13 or 14? Okay.
Good deal. WTY is representing. Good job.
The-
Okay. Let's go to the problem. To the problem.
Okay, Kiambra, it reads, Quinn is walking away from a motion detector. Gosh, we like those motion detector problems.
Yep, we really do.
Okay, the only information you have is that after 1 second, he was 7 feet away. And after 3 seconds, he was 17 feet away. Okay? Mm-hmm. So here we go. We're walking away from the motion detector. Or is that going to be a positive line or a negative line?
Negative.
Say it again.
A negative.
Say it again.
Positive.
There you go.
Good deal. Okay, so here we go. We have what information do we have, baby?
Can y'all be quiet, please?
Okay, what information do we have? We know that okay, it says the only information you have is that after 1 second
She's 7 feet away.
he's 7 feet away, and after 3 seconds he was 17 feet away. So over here I know that time is 0, 1, 2, 3, and 4. So what can I do over here?
1 you can put 7,
Okay, so after 1 I can put 7.
and 3 you can put 17.
Good job.
Good.
Good job. Okay. So now that we have this bit of information, how can we go from here to find out our slope?
You can count the Y, change the Y.
The change in y. So I'm going here. I'm going from 17 to 7, which is what type of change?
Minus 10.
That's minus 10. Okay, we're going backwards.
Up 10.
Okay, so that's 10. Okay, and then over here, this is what? I'm going from, remember, I'm
1
going
to
from
3.
3 to 1. Okay, so what is this?
Minus 2.
That's
plus 2.
that's a positive 2.
Same
Okay,
3 to 1.
Okay.
3 to 1 is minus.
3
You meant 1
to
to
3 to
2.
1.
Yeah, I'm going
Because
back.
earlier you said 17 to 7, so that's why she said minus 10.
17 to 7 is a positive 10. 17 minus 7.
From 7 to 17 is plus 10.
Oh, that's not okay. Okay, you all doing different. Anyway, come on, let's go
Okay.
to let's do the change in. Okay, so we know change in y over change in x. Okay, so here we go. Change in y is what?
2.
What's my change in y?
Oh, 10.
10. Okay, over my change in x, which is
2.
2,
5.
which is 5. Good deal. Okay, so my slope is
5.
5. Okay, so here we go. Where did I start from? If my slope is 5, then I can do what?
Minus 5.
Okay, minus 5, so that will give me
Negative. 2.
2. Positive 2. Good job. Okay, so now,
Somebody's frustrated.
what about at 2 seconds? That would be what? Bless you.
10.
That would be 10.
12.
That'll be 12. Good job. Okay, and then at 4, it would be what?
22.
22. Okay, good. Oh, I said 25. I'm thinking about the slope. Okay, so we know that we counted by fives. All right, so here we go. My y-intercept now is
0, 2.
0, 2. Excellent job. Okay, what about my function rule? What is it?
Y equals 5x plus 2.
5x plus 2. Excellent job. Excellent job. You are all over
And I
this.
had Miss Bean.
Okay. Okay, let's go to the table, to the graph. What are we doing here?
Where's your starting point, Canberra?
Oh, 0.
Okay, this is 0. Let's talk about naming the axis real fast. This is still going to be,
Count around. Oh, that's the time.
this is
Okay.
time, and what is this over here?
Distance.
Good job. Alrighty. So let's talk about what we're counting by. What do you want to count by here?
1.
Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5. Okay, and then what are we counting by over here?
2.
You said fives? Or you
On distance?
distance? Yeah.
Oh, you can count by 5.
Good deal. Okay, yeah, because we know our slope is 5 over 1. So we're going to go like up 5 over 1. Okay, so we know this is 5, 10, 15, 20, 25. Okay, so we have, let's just say that's 10 and that's 20. Alrighty, so go ahead. Tell me, where am I starting from?
Your
That
your
wasn't good
starting
idea.
point is 0, 2.
Okay, so I need to go to 2 and plot a dot. So where am I going from here?
You're gonna go up 5 over 2.
Okay, so
up
up 5
over 1.
Up 5 over 1. There we go. Then what?
Go up 5 over 1.
Up 5 over 1. Good job. Okay.
Up 5 over 1.
Up 5 over 1. Good job.
And now you can draw the line.
Now I can draw the line. So I'm imagining that Miss Ayala tells you all do about 4 points and then go.
Yeah, to make sure you have it right.
Okay. Good job. Good job. Okay. So now my function rule is y equals 5x plus 2. Wonderful job, W.T. White, and wonderful
Kiambra.
job, Kiambra.
Bye-bye.
Bye, baby. Y'all have a good day. Okay, here we go. We are going to our next caller.
Okay, we've got someone from Spruce, and I cannot pronounce your name. Can you tell me what that is?
Araceli.
Araceli. Araceli.
Oh, I can say your name. They just can't spell it here.
Oh my God. They can't spell.
Araceli. Hi, Araceli.
Hi.
Aw.
I got like Arastreli or something here.
Always mispronouncing my name.
Araceli. Hi,
Okay,
guys.
here we go. Are you ready for a problem, Araceli?
Yeah, Spruce knows what they're doing.
Spruce knows what they're doing.
Yes.
Let's go to work, Spruce. Spruce knows what they're doing.
Yes, they do.
Okay, here we go.
Araceli, it says Lou is walking away from a motion detector. The only information you have is that after 2 seconds, he was 8 feet away, and after 3 seconds, he was 14 feet away. So this is similar to the one Kiambra just did. So here we go.
Here we go. Did you see what happened in the last problem?
Yeah.
Okie dokie. So tell me what we're doing. We're going to, what do you want to do first?
The table.
Let's go to the table. Let's say this is 0, 1, 2, 3, and 4. Okay, so what do we got going here? At 2 seconds, it was how far?
8.
8. So that means I go here and put an 8. Okay, and then what else do I need to do?
At 3, it was 14.
Okay, so that means I need to put a 14 there. Cool. So what do we have here?
At 4, it was at 20 feet.
At 4, it was at 20 feet. Okay, good deal. Okay, and then going backwards?
2.
It's
On number
coming-
1, it was on 2.
2,
Yeah.
and then what about here?
-4.
-4. Okay, good deal. And remember, that means that the person started behind the motion detector, and the motion detector picked them up at 2 feet. 1 second. Okay, let's go. So what is my, what's my slope?
6.
6 over
1.
6 over 1. Good job. That means that the person was traveling, or Lou was traveling at 6 feet every second. Okay, so what do we have for a y-intercept?
-4.
-4. Good job. Okay, so now let's talk about actually writing this as an ordered pair. How would you write that as an ordered pair?
0, -4.
0, -4. Good job. Okay, so what's my function rule?
Y equals 6x plus -4.
Perfect.
Plus a -4. Good job. Okay, so let's talk about my graph. What am I putting on my y-axis and my x-axis?
Time is your x-axis.
Cool. Okay.
Good.
And y is your distance.
Y is distance. Good deal. Okay, so let's keep going.
Time go by fours.
Okay, on time I'm going to count by fours.
I mean, by your two. I mean, you know, like 1, 2, by one.
By
Okay,
Yeah.
by ones, 2. Okay, here we go. 1, 2,
okay.
skip a few. 1, 2, skip a few. 1, 2, skip a few. Okay, so that's 1, 2, 3, 4, 5. Okay.
And your y go by fours.
By fours. Okay, here we go. We're going to say -4, 0, 4, 8, 12, 16, 20, 24. Okay, so let's just say that this is 12, and then we'll know what everything else is. Okay, so go from there.
Okay.
Ha 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 ha. You wanted to count by sixes.
The point.
Go ahead, dear.
First point 0, -4.
Okay, here we go. We got 0. But you know what? I really appreciate that you know that you want to count by sixes because you that means you understand the problem. Okay, so we're going to 0, -4, and then where are we going from there?
Up 6.
Okay, which will be up. That's up 4. So halfway between there will be 6, and over
1.
1. Good job. Okay, and then where am I going from there?
Up 6.
Up
Over
6. Okay, so that's going to be, we're at 2, so we need to be about at 8, and 8 would be right there, and then over 1 you said? There we go. Okay, and then where?
1. Up 6.
Up 6. This is at 8, so that's going to be about 14, which is halfway between there, and over 1.
1.
Good deal. Good job. Good job. Okay, so here we go. We're going to start right here, and we go, I hear some clapping going on.
Good, Allison.
Okay, here we go. So that's y equals 6x plus a -4. Tell me another way I can write this.
Instead of plus -4, how can you write it?
Instead of plus -4, I can say y equals
Y equals 6x -4.
minus.
I mean -4.
There you go, -4. Good job. Okay, here we go. Check and a 100 to go along with the applause that you've already received. Good job, Araceli. Good job, Spruce High School, for being
Muy
so
bien,
spirited.
Araceli. Great job. Woohoo!
Okay, next we have someone from Griner. Someone from Griner, are you there?
Someone from Griner. Hi.
Tishi.
TC's your name?
Tishi.
Tishi.
Tishi. Oh,
Tishi.
I heard like
Tishi.
T and then C.
I got you,
Anyway.
Tishi. I got you, Tishi.
Hi, Tishi.
Hi.
What are you doing?
What are you doing, Tishi?
She's waiting to get on the air.
Okay, here we go.
Here we go.
Here we go, Tishi. Let's do this one because it's going to close out our show. It's going to, and it's a short problem. So let's go here.
Here we go.
Okay.
T-sheet. It says Phil is running away from a motion detector at 9 feet per second. So running away. What did we learn from Spruce? Running away. Is it positive or negative?
Negative.
It is positive. Good
I
job.
smell it. Positive.
No, it's positive. Remember, when you're leaving the motion,
positive.
yeah, when you're leaving the motion detector, it's positive. When you're going toward it, it's negative.
Yeah. Okay. At 9 feet per second, and he started 2 feet away from the motion detector.
Oh,
Okay. So they gave us a slope, didn't they?
Huh?
They gave us a slope.
Uh-huh.
What's a slope?
2 feet.
Slope is 2 feet away.
I mean,
If he starts 2 feet away, then that means that that's our what? What's starting 2 feet away?
Okay.
hello?
What would 9
Okay.
feet per second be?
Huh?
9 feet per second. That would be your
Slow.
slope.
Good job.
Right.
Good job. Okay, good deal. So tell me this. Look, okay, it says he started 2 feet away from the motion detector. So that would be my what?
Y intercept.
Yeah. they
Okay,
told you
good
where to
job.
start
Good
it.
job. It's going to be my y-intercept. Write it in an ordered pair form. It's going to be what?
0, -2.
0, not -2 because it
I mean
says
2.
just a 2. Good job. Good job. Now, I want you to take this y-intercept and I want you to put it in my table. It's going to, and put it as the first point. What would it be?
0 for time and 2 for distance.
Good job. And I want y'all to know, whenever you see the 0 in the x column, that means that is going to be your y-intercept, all right? So here we go. Let's go ahead and finish filling this out. This is 1, 2, 3, 4. So if I know that he is going 9 feet per second, what does that mean? He's definitely running. That's fast.
It's 2 plus 9 equals 11.
Okay. 2 plus 9 is 11. So at 1. Okay, and then where?
20.
20. Okay, and then where?
29.
29. Good job. And then where?
38.
38. Good job. Good job. So now let's go down here and write our function rule.
Y equals 9x plus 2.
Plus 2. Okay, and just quickly tell us. I'm not going to do the graph because we're running out of time here, but I want you to just quickly tell us what would we do on here? This, so x will be our what?
X will be time and y will be distance.
And I would start where on my graph?
At 0.
I would start at 0 and then go where from there?
0, 2.
Okay, that would be my, and then that would be my y-intercept, and then what would I do from there? Go where? Up.
Go up. Go up 9.
And over what?
2.
Over.
No, over 1.
Over 1. Excellent job. Good job. Good job.
Tishy.
Excellent job, Tishy. Okay, that was
Our last caller.
That was our last caller.
Bye,
Thank you.
Thank you.
Bye.
Thank you.
Bye-bye.
Let's go back a little bit.
Okay, rewind.
Okay, here we go. That's just about all the time we have today. But before we go, what do we need to do, Nadia?
Okay, we're going to give away the prizes that we have today. So who is the lucky person? And we're going to give 3 prizes. We're going to give 3 prizes today, like we said earlier.
We're going to give away 3
prizes away. So let's go ahead and let's pick randomly, you and I. I've got
Okay.
all the names here.
Okay, good deal.
You want to go by?
Let's go by, you close your eyes and pick a number, and then I'll close my eyes and pick a number. You pick a number.
Okay, 2.
2. Okay, we're going to deal with 2, and we're going to deal with,
Who?
let's say 7.
7. Okay, and then I'll pick 5.
Okay, but 5, okay, cool. Okie dokie. So what do we have here?
Okay, number 2, and who gets the calculator?
The calculator will be the other person. Just pick somebody. Don't tell them.
Okay.
So here we go. Let's go. Here we have the first winner for the watch. The female watch is right here. The female watch will go to, is this Ryan?
Yes, Ryan
Okay.
from WTY gets
Ryan.
the watch.
Good job, yay,
I'll give
Ryan.
her this. She's mine.
Okay, and here we go. Jonathan from Atwell is going to win the male watch. Good job,
Yay.
Jonathan.
And then the calculator.
And then the calculator is going to go to Araceli.
Araceli
from Spruce. Good
And
job.
We got someone from
Yeah, so almost won this one. Good
Okay,
job.
congratulations.
Congratulations, guys. Okay, go
Okay,
ahead.
remember we would love to see you, so don't forget to bring pictures to your teacher
Please,
so
guys,
she
bring
can
us
send them
pictures.
to us. Our email address is algebradudes@dallasisd.org.
Yes, it is.
You can also send them through interdepartmental mail to DISD Box 379.
379. Okay.
Okay.
Thank you for joining us today, and we'll see you next Monday, guys. We don't expect you all to have an understanding coming on, but we definitely expect you all to have an understanding going off. We'll
Yes, we
see you
do.
next week. Have a great week, guys.
Hasta luego.
Hasta luego.